The DevOps project aims to close the gap between today's and future's skills demands of municipal workforce, by emphasizing on the exploitation of emerging employment paradigms. Its mission is to develop job profiles for smart cities DevOps professionals. DevOps project is an Erasmus Plus project and it has been funded with support from the European Commission.
Competence description. DevOps approach is based on continuous integration and continuous delivery practices.
Continuous integration is the practice of automating the integration of code changes from multiple contributors into a single software project. It allows developers to frequently build code into a central repository where tests are then run.
Continuous delivery is the practice in which teams release reliable software automatically and quite frequently.
This course module provides the trainees with the main introductory concepts on build, deployment, and monitoring tools within the DevOps framework.
Learning objectives. The learning objectives of using build, deployment and monitoring tools module are the following.
To understand build automation practices in DevOps.
To be aware of deployment practices, routines, processes, systems and tools for building either applications or entire end-to-end services.
To understand deployment practices, automation, and tools.
To be aware of the monitoring techniques and practices for operating services. Competence content. The competence content is divided into the following units.
Build and deployment tools.
Monitoring tools.
The first unit analyzes build and deployment tools in DevOps. The most common automated build and deployment tools are presented.
The second unit describes monitoring techniques and tools in the DevOps approach. The most common monitoring tools are presented. What is software build? A software build specifies how the software is to be built, what steps are needed and in what order, what dependencies are required, and what other software is needed to be present for the build to succeed.
Software build is the process in which source code is converted into an executable software application.
The general steps of a typical build process are:
fetching code from a source control repository,
version control, workspace creation and updating, baselining and reporting,
code quality, static program analysis,
compilation, converting files into executable code,
linking libraries, files, etc.,
checking dependencies and modules,
testing.
Build automation. Build automation deals with a wide range of tasks that software developers need to perform.
It is the process of scripting and automating the creation of a software build and the associated tasks.
Some of the most notable actions that build automation deals with are:
retrieval of code from a repository,
compiling source code into binary code,
running automated tests,
publishing into a shared centralized repository. Build automation is often regarded as the first step towards implementing the culture of continuous delivery and DevOps. Build tools. Usually, builds are created when either a certain point in development has been reached, or the code has been deemed ready for implementation, be it for testing or outright release. Features provided by DevOps build tools are:
continuous integration, for example, cruise control.
Incremental builds, for example, Gradle.
Control over the whole build process, for example, Apache Ant.
Build tools are devised so to require very little human interaction, to help developers improve their productivity. The setup of any DevOps tool requires knowledge of
the actual build process,
the requirements that come after that,
unit testing, continuous integration, regression testing, performance testing, etc.
What is software deployment? Software deployment is the process required for preparing a software application to run and operate in a specific environment. It involves
installation,
configuration,
testing and
optimization of software performance. Deployment automation. Deployment automation enables us to deploy the software to testing and production environments with the push of a button.
An automated deployment is a form of deployment where the defined steps for shipping code from a development environment to staging, production become a one-step procedure, fully or partially automated.
To automate the deployment process, one needs to take care of
The complexity of the existing process.
Dependencies and orchestration.
Components that may be not designed for automation.
Automation is essential to reduce risks in production deployments and to provide fast feedback on software quality. It allows teams to perform comprehensive testing as soon as possible after applying changes. Deployment tools. To simplify the deployment process, several tools are available. They can bring many key advantages to enterprises, allowing for
time savings,
security enhancements,
better user activity monitoring and software updating,
maximization of developer time,
minimization of release risk.
Some important features of deployment tools are the following:
easy distribution of builds across multiple machines,
fully scalable deployments to any environment,
repeatable and on-premises deployments with automatic scaling,
centralized control by monitoring deployments and their history,
pushing of code to many servers at the same time,
running deployment tasks simultaneously across servers,
application release and deployment to coordinate with business processes,
complex workflows for fast feedback and on-demand deployment,
containerization,
source code management through branching tools, etc. Competence learning outcomes. Among others, upon completion of this module, the learner will be able
to describe the build automation process,
to know tools that automate continuous integration process in DevOps,
to be able to describe the deployment process,
to know tools that automate deployment process in DevOps,
to be able to define a monitoring process,
to know tools that automate monitoring in DevOps,
to be able to understand the advantages, disadvantages of automation in continuous integration, continuous delivery, and monitoring processes.